So, this is a subject that, and this lets me talk about some things that I have seen over all of my career. Quality has been a part, and software quality has been a part of my life throughout my whole career, because as it started, it actually started before my career did. Let me take you back to 1986. Anybody remember this? Challenger accident, right? It didn't make it very far. It was a big fireball over Florida. And there was a lot of fallout, not just, actual parts that fell, but there was a lot of, why did this happen? How did it happen? How could this possibly, happen again? What are we going to do about it? So there's a lot of social things about that flight. The first non-astronaut on the flight, a teacher. At the time, the idea of we were going to be pushing into space with the shuttle was very real. And as part of figuring out what went wrong, a culture of pushing and go, go, go was noticed as a part of the problem. And that's kind of what we've seen, right? Besides all the technical details about O-rings and everything else. But actually, another part that came out was very important. And this is the National Research Council report. The Post-Challenger Evaluation of the Space Shuttle, Risk Assessment and Management. So, you can go and read this. It's actually, if you are into things like safety, stuff like that, it actually is fascinating reading. But it spawned this. In Fairmont, West Virginia is a small NASA facility that is called the NASA 4 and 5 Center. And it's not really 4 and 5, it's IV&V. And because actually people in the area call it the NASA 4 and 5 Center. Because if you notice, there is no explanation of it, just says IV&V 4 and 5, but it's actually IV&V. And what it stands for is Independent Verification and Validation Facility. Now, one of the persons that was on that report, Nancy Levison, is very influential in the safety community. She's worked on air traffic control systems. She's worked on medical instruments. And she had a lot of stuff to say about the current state of how software and shuttle are leading to a problem, and it has to be addressed. Safety is an emergent property of a system. It's not a component property. You don't make one piece safe and then say, well, look, hey, the whole system's safe. The whole system has to be safe or it's not, right? So it's software safety. That leads to mission safety when you think about it from the NASA perspective. Getting the mission done, getting the mission so that it works, getting the science done, getting everything done. And doing it with no loss of life, no loss of spacecraft, and as little loss of money as possible. And what work that has been done at that facility is shuttle. I started as a graduate research assistant, working on systems like shuttle. In this photo, how many systems do you think are involved to get it off the pad? Ground control systems, systems on the shuttle. At this point in its takeoff, Johnson Space Center is not doing anything. It has no responsibility for shuttle at this point. Not until it clears that very tippy top of that antenna. What else is being done there? Everything's being run from Kennedy. Ground systems. All kinds of things are running at that point, not just the shuttle. In fact, the least amount of systems running right now are in that cockpit. So these are large systems. This is the shuttle after it was updated with the glass displays. It's not a simple system. The shuttle was never simple, but it was very effective. ISS, another not very simple system. Lots of subsystems, and not all of them are actually on station. If we look at ground systems alone, there's millions of lines of code in those systems. There's millions of lines of code just in Johnson to do various things with station. So it's a task getting these things up into orbit. It's an even bigger task keeping them in orbit so that when the bad things do happen, these systems don't break down and all of a sudden start plummeting to Earth. How big do you think the teams that do this kind of activity of making sure that independent verification and validation exercise is? And what that is an independent entity that verifies and validates that these systems work like they should. How big do you think these teams are? 1 to 2 or 5 to 6 people is pretty common. Small budgets. Some of them don't have any budget. And not in the any budget, no budget, so they can just do whatever they want. But in the, how in the world do we do all the things we have to do with no payment, with no budget whatsoever, and have to move money around between projects to do it? But it's not just when people die. This is Cassini. Cassini was a very successful mission. I worked on various parts of Cassini. Everything from some of the launch stuff to actually how some of the kernel actually in the strands within the probe itself work, and various things and various subsystems. The logging subsystem, how it actually, if there is a problem and it recovers, how does it recover? It rolls time back to a previous state. It then moves forward from there, and it periodically marks and snapshots its state. Very similar to something that Martin may have talked about last talk. Mars rovers, Mars Space Lab uses IV&V techniques and actually verifying that the rovers can do what they want to do and need to do, and what kind of mission parameters they have. But it's not just NASA. Our markets need things like IV&V. And there are entities out in the world that actually do for almost any type of system that can be deemed critical, can do these kinds of activities. And it's more relevant every day. In the US, probably most of us here are from the US. There's a few non-US I know around. But did anyone try to file your taxes on tax day electronically? Good thing you couldn't. Got an extra day because of it. That's great. It's like a snow day, right? But notice right over there the little error message. It's a planned outage. April 17, 2018 to December 31st, $99.99. Excellent. This did cost the government quite a bit. I don't want to make too light of it. Maybe I should. But really, it's we see this, and we see this with other things too. Singapore, the first Bitcoin lawsuit, judge asks if law is enough to deal with IT errors. Night Capital several years ago now. Spectre and Meltdown, which have a large impact on software, even though it's actually a hardware issue. Well, you can think of it as a hardware issue, but it really is software as well, just because of how we design chips. And we could go on. There's lots of these, and it's been covered in lots of different talks, in today and yesterday. Let's talk about software quality. Most people don't expect software to work. A couple years ago, I had this theory that I don't think most people expect software to work. And so I asked a lot of friends and family that are not in the software industry, what they kind of expected. And most of them said they don't expect when they go to a web page for it to work. When it does, it's kind of, yeah, great. And when it doesn't, it's kind of, this again. Their phones, their apps, different things like this, they just don't expect software to work. And large projects are really bad. Our success rate is pretty terrible. Building bridges is a lot better than we are. And that's pretty bad. We're the only industry, and I've been trying to find any other industry that has anything like a EULA, which says we have no responsibility for anything which may result from the errors that are in this. No other electrical product has that. No mechanical product has that. Software quality. Systems meeting functional requirements. That's how we think about quality, right? But words matter. Words and ideas can change the world. This is either a great service or a sitcom waiting to happen, right? Non-functional requirements. That's what quality is. Non-functional. And these are just some of them. Performance, quality, robustness, safety, stability, usability. These are all non-functional. Our use of words here matters. When we don't meet these, is the system not non-functional? These are some of the examples. You're not really supposed to be able to read that, so don't feel bad. Don't squint too bad. But these are unspoken, incomplete functional requirements. That's what they really are, right? Is, of course, the system should, be safe. Of course, the car should not drive over someone. Of course, the shuttle should take off, right? Quality at best is usually an afterthought. And quality, like a lot of different things, security, scalability, a lot of it isn't an issue until it suddenly is, right? Most of us, and we've all fallen into this, so don't feel bad, but management especially within large projects usually goes, well, of course it's going to be a good quality, and all of a sudden when it's not, it's a surprise, right? Because we usually go, what could possibly go wrong? Oh, it went wrong. So what do we do? Well, this is a common sort of cycle. Something went wrong, something really bad, so we throw testers at it because we don't know how bad it really is. We come up with patches and hotfixes real quickly. Then get those out, fix the immediate problem, and then we institute, to avoid this in the future, source code reviews. And then because we find so many other things, because we threw testers at it all of a sudden, and we've instituted source code reviews, we found a whole bunch of bugs. So many bugs that we have to actually have triage meetings to determine which bugs we're going to address and which ones we're just going to let sit there and hope that no one notices. This happens all the time. This is really just a placebo, right? We're convincing ourselves that that's how we should deal with quality, reactively and with as little work as possible. But let's think about it. If we take a view and we think, if we really want to address this, what kinds of things aren't quality? And what I mean here is, I'm going to give at the end, I'm going to give some references you can look at that have a lot of different ways that you can invest in things that will get you better quality and get a return on them. And this data is distilled from different NASA projects and ones that I worked on and have seen. What I'm going to say is, what has been shown through that return on investment, there are several things up here that don't have as much impact as you would think, but we're definitely told they do. Agile, waterfall, Scrum, your process is not quality. Your language choice is not quality. Your framework library choice is not quality. Your formal method is not quality. Your decision of functional versus imperative or object-oriented is not quality. Your reference enterprise architecture is not quality. Your vendor stack does not give you quality. All this is really snake oil. But it gets better. Use of terms when we refer to things within our systems, things that will never happen, or things that will always be there, or that we should always do. Your recruiting process, your web-scale architecture, your distributed algorithm, AI, big data, IoT, reactive OSS, what anything else buzzwords, these do not provide you with quality. Source code reviews don't provide you with quality. Bug triage meetings don't. Code coverage does not. Your comprehensive test plan does not give you quality. In fact, a lot of the dogma we have is really detrimental to quality because it doesn't let us actually ask the appropriate questions that we should always be asking. Now, it doesn't mean that there's no value in any of these things. It just means that by themselves, they're not going to give you all of a sudden make your product better. They can help, but by themselves, they're not going to. You have to invest in actually doing the right things anyway. So I look at these more as inspiration. The highest purpose of art is to inspire. What else can you do? What else can you do for anyone but inspire them? That's what I think about for languages, right? Java and C++, C#, a lot of safe languages beyond these that are listed, even things like JavaScript, what they do is they inspire ways that you might want to think about how to solve a problem. And that's really how we should think about all of our technologies. They're inspirational. They can give us the idea that, there may be different ways to solve this that might be better in certain situations. Even things that, you may not value as much because they may not be, quite your cup of tea, like ORMs or DI for me, or RPC. There's still some inspirational stuff there. Now, it may be de-inspirational. It may be an itch that someone had and they had to scratch it and it turned into a rash. But it's still, if you think about it that way, instead of like, something else, like a silver bullet. This is a great article. You should read this. Fred Brooks put this out, quite a number of years ago. This is late 80s. And it talks about, that there is no silver bullet. There's no simple thing that will all of a sudden fix everything. That it takes actually us, really actually being smart and being critical of what we do. And, it's hard. It takes a lot of thinking to do these things. So what I want to do is point out some sort of case studies of projects that I've seen where even when I have thought a lot of the project was done really, really well, that there were still things that crept through. And all these are going to be, I tell you, you're going to look at them and go, well, of course someone noticed that. And trust me, a lot of these things just eventually appear and some can hide for years. There was a project that I was involved in very early on that had a mandate of 100% code coverage. If you put a branch into the code in some way, you had to figure out a test to actually cover it. And what that had led to was, now it wasn't intentional, right? No one went with the idea that 100% code coverage, someone's not going to do error handling. But it happens, right? So when you put in something that you should be checking for the result of, or that there's an error present, or something else, if you've got a mandate of 100% code coverage and you're not sure how to make the test that does that, what do you end up doing? I hope nobody notices this. Git commit. Error handling is hard. Michael Feathers had a great talk earlier mentioning error handling. I'm going to show you one that I ran into twice. I did this twice. A system where you create a file, it gets dropped into a directory, a messaging system of some sort that will not be named transfers it over to a receiver process where it is then processed by another entity. Very simple. This, you can think of this as the cockroach of data integration. It's been done so many times. The problem here is that create file. Here's what it might look like. You create an empty file, you check params, do some sanity checks. If things don't look good, you go to error. You unlink the file, you return with an error. If everything's fine, you fill the file and you return 0. Nothing could possibly go wrong here, right? This is C. You're doing a lot of other checks in here and all of them going down to error. It's all wonderful, right? Actually, it was Java. The first time it was C. Second time it was Java. Looks kind of the same, kind of has the same problem. What can go wrong here? Sorry? No. Possible. But that's not the problem. It's a different problem, but... Huh? Oh, yeah. Huh? Could happen. Even simpler. You create an empty file. You check the params. You fail. What have you done? You created an empty file. What happens if your receiving system doesn't like empty files before you delete it? You can transfer an empty file really quick. Does this happen often? No. Is it hard to make it produce this? Yeah, it's a race. What happens when you see this? All kinds of havoc on the receiver that you never anticipated because it's an empty file. It shouldn't be there. So, looks easy now, right, when you look at it. Is not easy when you're doing it and you've done it twice. The second time you do this, you're like, okay, I'm putting this in my brain that, process empty files correctly, one. Number two, don't create empty files. But beyond this, we have systems that are vastly distributed. And we go to great lengths, if we really need to make sure that things can operate in somewhat of a unknown state. Keeping things up to date is actually quite difficult. Keeping up to the latest versions, keeping things so that they are compatible with one another is hard. Here's an example. This was intentional. The system was a request response system. There was a service here that understood, the request, and they wanted to add some logic here for saying that there was some state that should be carried over implicitly. And the easiest way for me to sort of demonstrate it is this SR latch. And what this means is if S is high, then the output should be high. If S is not, then the output should be 0, but you have to have the reset bit set. And if there's 0, then you should have the previous state. Now, the reason why this was chosen is because in the case where there's no flags here and there hasn't been in the previous version, these will be 0. Which means that you just go with the previous state that you were in. Hey, this sounds perfect, right? You may look at this and go, it's not a bad idea. That way I can kind of add these flags, and I only use them when I need to, and if they weren't there, then I use the previous value that I want to use. Okay, all right. It has one big major flaw. One side believes it's in one state, the other side doesn't know anything about these flags, so it thinks, I don't even need to read these. In other words, the client thinks that the service must have Q equals 1, right? But the service doesn't even know what Q is. So you can't upgrade the service side independently from the client. You have to upgrade the service before you can upgrade the client. That simple dependency that is obvious when you look at it is not so obvious when you're initially thinking about how this is going to work. Until you run into it, it doesn't work how it's supposed to, and systems are failing. Last one here is make everything asynchronous. Originally, a system had a request response. It was a blocking request response. The systems had the property that if after a period of time it does not get a response, it sends the request again. After it's sent so many times, it has a timeout. The system would get into a state where it would send a couple requests. The other side was just gone, and it would time out, and then the service would time out because it hadn't heard from this side in a period of time. So both sides timed out. And this led to all kinds of other havoc. And it wasn't assured that, what was happening here on that side, on the service. Why is it going off into la-la land and not responding? Well, so this must be an asynchronous problem. If we turn this into asynchronous, something that's asynchronous, it will all go away. Well, how do we do that on slides? We just actually erase those lines right there. So now it's all asynchronous. Still happens. Okay, well, what was the problem? You know that thing about computer science where, all problems in computer science can be, fixed with just another layer of abstraction, right? The problem here was that the system that went into La La Land was actually sending a request to a different system, and that system was going into La La Land, right? So finding out what the root cause of a problem is and figuring out if you're addressing the root cause, it matters a lot. Making sure that you're fixing the right thing. This actually happened in a system that had specs that were like this. I mean, just a tremendously big system, lots of detail, Everything was actually put in front of a lot of different people, and a lot of different people signed off on it, and they still miss this. So we talked about what quality isn't. But what is quality? What is it really? It all boils down to this. After I've seen so many projects, everything from Shuttle Station, Cassini, the Mars rovers, some of the earlier ones, and even some of the later ones, through friends and everything, and had seen a lot of systems outside of that, even finance. It comes down to really one uncomfortable truth, or maybe it's a comfortable truth. It's the pride, ownership, and responsibility we as developers have in what we're doing. All the other things about, safe languages or how we handle errors and everything else, it matters, but it only matters once we have that. One of the things I used to notice when I would work with some of the teams within NASA is words that they chose to explain what the system does. And it all comes down to that pride, that personal commitment. It's really an attitude that does separate, excellence from mediocrity. The words that were chosen by developers when they're explaining how systems work actually matters. And this is kind of how I noticed it. I do this. That's showing ownership. The system does this. But I do this, right? I'm putting myself in the system's position. It does this. That's divorcing yourself from it. And that may be good for certain things, right? But what's even more impressive is the teams that I noticed that did that. We do this. That shows another level of commitment than more than just I've internalized it to myself, I've internalized it to the group. It's a simple thing, but it is a difference. It is something I noticed that did separate the teams that were kind of just there going through the motions, that used kind of the it language. And the ones that were pretty good but still, had room for improvement, which were using I. It was a team of individuals, right? And in the teams that were really good that I noticed that they talked about things like, we do this. We send this message. We get this message. It does matter. It's a simple thing, but it does, I did notice it. And it really comes down to this quote by Pat Summitt. Responsibility equals accountability equals ownership. And a sense of ownership is the most powerful weapon a team or organization can have. Once you have that, there are vast numbers of tools that can help, to build better systems. But it all starts with that. We have a lot of challenges. How many of you have heard of Putt's Law? Or Putt's Corollary? It's real simple. It's sort of like Dilbert. Technology is dominated by two types of people. Those who understand what they do manage, and those who manage what they do not understand. Right? Think about that for a moment. We individually, as developers, a lot of times don't manage our own, teams and systems. We're just pieces of them. Management might be good, but a lot of times they don't know details of the system as we do, right? And corollary of that really is that, the competence inversion that results from that, right? Now, when it says competence, it's not talking about general competence, although we might like to think that, but it's really talking about the technical competence. There are differences in this. There are organizations who don't suffer from this, but a lot do. It actually is a really good read if you want to read it. We have to take responsibility, for ourselves and make this better, or it's going to be done for us. The Volkswagen engineer that was sentenced to 40 months in prison and a substantial fine for, his result of putting in a lot of the feat devices within the clean diesel, software for the Volkswagen cars, kind of shows that, engineers, we're going to be responsible. We're going to be starting to be held responsible for the things we do, right? And even better, the idea of management saying, I had no idea that an engineer was doing this. Whether that's true or not, we have to think that we are going to be held responsible. One of the things that I experienced before I graduated was the last exercise that I had as a senior in electrical engineering was an ethics discussion. And the ethics discussion was, you have designed a system. Someone has died. Now justify your design choices within the system. Why did you do this? Why did you do that? It was put on like a trial. And it instilled in me that, my decisions as an engineer might have repercussions. You can go through class, you can go through your whole undergraduate career and never realize that. But when you're faced with it and you're put into like an ethics class or something like that where you have to think about it, how do you do that? Have you really made the right decisions? Now, most of us won't be in that position. Most of the systems that I worked on, I didn't actually make the decision. I was coming in looking at the decisions and how things worked. And then trying to figure out, does it do what it's supposed to do? What are the failure modes? What are the different ways that this can work? But here's sort of a takeaway from this. This kind of sums up a lot of the things that I think, are really useful. So think of these as what you could tell your boss. The return on investment of quality is pretty well defined within NASA. In fact, here's just a few references that the slides are going to be made available, so you don't have to start writing these down. And please don't start writing down links. That would be, please feel free to take pictures, whatever. But this is available and will be available with the slides. I apologize for the way that some of these URLs look, but I didn't design the web, I only use it. These are about return on investment of lots of different, most of them are NASA, but there's a few others that are scattered in there. There's some .mil stuff. And this is, what kind of things can you do and what has been shown with different data to be, good return on investment from a, standpoint of improving quality substantially. Here's a few other people who have done work in this area. Alan Nikora and Martin Feather from JPL, great individuals who've done a lot of work in software safety and reliability engineering. Lampport's done so much stuff, in computer science, but one of the things he has done is to look at model checking and things like TLA plus as a means to kind of look at systems in a different way and to use some techniques that we can do to improve what we do. It's just as important. So the point of your boss takeaway here is we don't need to write mountains of specs. Our specifications can be our communication. As long as we are good about how we use our words and our naming and things like that, we can use specifications as a communication mechanism so that we get on the right page with one another in a team. And that's the value that they have. The artifact itself, a document, is pointless. It's the actual act of communicating and understanding and asking what if to one another that's important. The earlier you start to be practical about analyzing what the system's supposed to do and really asking questions and thinking of scenarios, the earlier you do that, the better. If you have the luxury of having some access to someone who's a domain expert in something that you're coming into, don't hesitate. Send that email. Send that question. Call them up on the phone if you really want to. Send them a text. Send them a buggy email on LinkedIn saying, hey, we're working on something. It's kind of like this. Wondering if I can pick your brain about it. When you come to conferences like this, there's a lot of domain experts. Ask them. Don't be afraid to. And have a culture of accountability. Hold each other accountable. When someone wants to, well, I'm just going to hack this up, and that should address the bug, right? And all of a sudden, they run it, and oh, look, the bug's gone. We'd really fix that, or did we just kind of cover it up with Bondo? right? Have that culture of accountability. Make sure that, you're doing it right. Here's kind of suggestions for us, right? I think things like TDD and BDD are the spec, right? The things that we build that say, here's what the system should do, and we test against it, that's our spec. That's a spec. That's a form of specification. The actual act of creating that is entirely, just massively valuable. Property-based testing also goes in this area, right? The building of that is important, and having it there as a runnable thing that we can do is incredibly important. Now, I said, Agile wasn't quality. What I meant was, all right, lip service to Agile. But if the actual intent of Agile, the fast cycles, the values that are there in the manifesto, if you actually look at the intent of that, that does help. So don't just have Scrum and instill, or stand-ups every day and then deliver every 6 months, with feedback. That doesn't help. The intent of it is fast, results and feedback, and having the ability to change quickly. Things like continuous delivery, things like, continuous integration, incredibly valuable because it's building that faster feedback for us. Language discussions are great, but realize that, just because you're using Java doesn't mean that someone else who's using C has a less quality product than you. Most of the products out there that we rely on, the ones that we rely on for our lives, are written in languages that are unsafe. Now let that sink in for a moment, right? Do they work? I hope so. I got to fly tomorrow. But it really is. Don't fall into the trap of one language is better than the other. Learn from that language. Use it as inspiration. You may not be able to write something in Ruby. You may want to. But there's things in Ruby that you can really kind of use as inspiration to get better at, right? It's the same thing with functional or object-oriented programming or any other thing that comes up. Rise above the idea of one versus another, one better than another. Because I'll tell you, on the return on investment on this stuff, there's projects here that use all kinds of safe languages. There's things here that use all kinds of different approaches. Data flow, models, and a whole bunch of other things. It mattered jack. And don't fall for dogma. When someone says, well, you always have to do this, or you never should do that. There may be some piece of truth in it, but those are strong statements. Those are red flags. Is it really true that it's always that way? You mean I can't find one reason why that would fail? Think about that. Dwight D. Eisenhower saying the plan is nothing, planning is everything is really true, because the spec is nothing. The writing of the spec is everything. That process of, how many of you have just had an idea and you're trying to figure out how this can be implemented, and you just speak it out, to yourself. And all of a sudden you realize, oh, that was really dumb. That's not going to work at all. The actual act of forming those words, the actual act of writing them down, the actual act of putting that code down, even though it's not even hooked up and it may not even compile, you all of a sudden see things that you didn't notice, right? The act of doing that, making it tangible instead of just something that is rattling around in your head, immensely important. And the last thing is, above all, that pride, ownership, and responsibility starts when you develop good taste. And, it's something that Martin and I share, is that naming is important. The words we choose are important. The language we use to talk to one another is important. The shared idea of what something is important. But also, too, when you look at something and you say, that looks good to me, or that doesn't look good because it's all kinds of messy, or I don't like that name for this, that actually matters. Because at the end of the day, this quote from Steve Jobs kind of rings true for me, is for you to sleep at night, the quality has to be carried all the way through it. You have to be able to look at it and go, I am really, really proud of what developed there. Now, it doesn't mean that you stop. You might change your mind later and go, you know what, I don't like that choice of wood, to use that analogy, for that. That's okay. You got to be okay with changing those things. But have that taste that when you look at it, you're like, okay, I like that. That right now is good for me. It really does matter. Because what does it do? It improves that pride, that responsibility that we should have, and everything else. Thank you.
Thanks, Todd. We have some questions.
How do you deal with pride, responsibility, and ownership in an ever-shifting, money-driven environment? Like if I'm on a different team every 3 months, I'm on a different project every 6 months. How do I motivate myself to have ownership and pride when management thinks I'm a fungible widget and they're going to stick me on different projects when they need me?
When it comes down to, the first thing is you have to have that feeling that I have to make a difference within that team. I actually noticed with some of the teams because one of the jobs that I had at NASA was to go to lots of different teams and work with them on various projects. And I would come into teams that didn't want me there. They didn't want some academic, young academic kid who thought he knew everything, which that was me, unfortunately, coming in and saying, here's what you should do. And so a lot of people didn't like that. But I would, I'd start asking questions. I would, try to get in there. And the questions I would ask would be, things like, well, that doesn't seem right to me. Why can't we do this? Now, that actually was not my job whatsoever. But every time that I was put in that situation, I was lucky enough that I pretty much became part of the team pretty quickly because once you interact and you're asking questions, if people have already some amount of pride within what they're working on, and you say, that's pretty good, but couldn't this be better? They'll look at it and go, hey, you're right. And that trust starts to develop. So I think that it is hard, but the only thing is you have to show value to the team that you come into. You have to start, letting them see that you're vulnerable, right? That that you're fallible, but that you're not afraid to say things like, hey, that's really good. I like that. Here's why that's good. And can we do better here? And start asking those questions. And all of a sudden, people like to follow, right? There has been teams that I've come into and it's been a total train wreck, right? But there has been teams where I've come in and it's like within just a couple days, they went from sitting like this in a meeting to going and looking like that. So it's hard, but it can be done. But it's work.
Other questions? All right. Thanks a lot, Todd.
Thank you. Thank you.